All right, so the back end here, we're going to talk about some tooling. We're going to speed run a lot of it. Now that we started 10 minutes early, maybe we don't have to speed run it quite so hard. So one of the things we have is Jordan and I teach classes and about Active Directory, about different tooling that you can use, about pen testing. And to do that, we need to have some sort of lab environment that we have students in. So we created a bunch of ARM templates that help us with that. So ARM is Azure Resource Manager. It's essentially, think of like Terraform, if you're more familiar with that. It gives you the ability to just spin up things in Azure relatively quickly. The reason we are using Azure over something like AWS is because a lot of one of our classes focuses on Sentinel, which is Azure Sentinel, which is kind of like a SIEM. Kind of think about it that way. So we talk a lot about that, and having it all in one place helps us. If it weren't for that, we'd probably do something like AWS instead. So we use ARM templates for that. ARM templates are JSON-based. It's essentially infrastructure as code. So you just deploy them into Azure. The easiest way to do that, I don't know if Jordan's going to show that, maybe you can, is if you go to www.doazlab.com.
There's a landing page.
Like this. And if you scroll down just a little bit, there'll be a button that says Deploy to Azure. And you click that, and about 30 minutes later, you have a fully deployed Active Directory environment. So it ends up being a domain controller that is Windows.
Those of you with the physical copy can switch over to page 6 and take a look at the lab environment once it's constructed. It also looks something like this. So now we have to switch one box on here that was a Windows 10. It was fascinating because, was it yesterday?
Yesterday.
The Windows 10 SKUs on Azure fully deprecated. So our builder was good up to yesterday.
They're fully deprecated on US regions. They deprecated. I imagine they're still available on European regions for another year-ish.
So when you click that button and deploy this thing, it comes up like this. We have a Linux box on the edge of the network. You can SSH to that on its public IP. We also expose an RDP listener on a domain controller and a workstation. The workstation and domain controller are joined together. They talk to each other, so we can do all that thing. This is on an adjacent network, slightly different. But again, page 6 has this picture. This picture is in the repo. Once you click this button up top here, it does deploy that infrastructure that you see or saw previously. So we're going to click through.
Ingest a bunch of vulnerabilities that we use in class as well.
This is very much a click, 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 done lab build scenario. Okay? So here we go.
Our students always ask us, how much does this cost? It's around $3-ish per day. Now that said, one of the questions on here is to select a VM size, and we've kind of strategically given a small option for sizes. There's nothing from you changing it for the fact that you could go change the ARM template and go make it $200 per day VM size if you wanted to. Not practical to do that, but you certainly could.
There are some differentials between regions, right? So if you deploy to West US, it's a little less expensive than East US, Central US. There's pricing differences, but it's about $3 a day for these labs. So for us, it's spin one up, test a thing, break a thing, show off a thing, make sure we can do something before we go into our customer environments and run tools. If we haven't seen something before, we got a scenario where we haven't run something from GitHub before, we will do that here. And then the environment's ephemeral, we blow it up.
When we first started doing this about 5 years ago, we eventually did get some notifications from Azure that said something along the lines of, we've inspected your system and found Mimikatz. I'm like, yes, you did. And yes, we ran it, expected. And then that prompted a conversation with them, and I think we're on a list somewhere with Azure that says, oh yeah, expect this. So from that platform, though, if you think about this, yes, we have an AD environment. Oftentimes when we're doing pen testing, we have customers, and we might have a finding, and that finding says, go do this remediation. And what we don't tell you is to do that in change management, right? Because that is what you're supposed to do. So we do have customers that come back and say, well, I'd like to know what that looks like before we deploy it in our own environment. And we always say, well, do change management, go through, select a pilot group to deploy to, but you can also go here or do something similar, have a fully functional domain, run through that process on here so you can see what that looks like before you even deploy in your own environment. So anytime you need to do something in AD and you're like, oh God, where's this at? Where's this setting at in Active Directory? I don't want to log into my own domain to do it. You can run this really quick. 30 minutes later, you have an operational lab environment you can go and change everything to. And then 45 seconds later,
we do have one left. Does anybody want it? There was another call we got from Microsoft during this process, and they said, hey, are you aware you're putting yourself at exposure for millions of dollars in cost per year? We said, whoa, really?
And then they wanted all of our financials. So
And that's just because as one of the things you have to consider when you deploy these, say you just spin up your Azure account, you got a brand new, clean, shiny default Azure account, you only get 10 CPUs. You only get X amount of RAM. You only get X disk space. So then as you expand your use of their environments, you also have to expand your quotas to support expanded size and operations and systems. So then they call and say, are you sure?
What is odd is after that conversation with them, they completely over budgeted us in ways that two blokes in South Dakota shouldn't have so many resources.
All right, on screen. And we can limit ACLs. We leave it wide open. We're going to show you something if we have a couple minutes at the end. What's happening to RDP systems after you expose them to the internet? So then it does this thing, validation. Yesterday it said, sorry, no more Windows 10 SKUs. So we rolled this to Windows 11. So if you deploy one of these today, you are going to get a Windows 11 build. Our lab environment is coming up. It'll come up in about 30 minutes. So done. This is it. The workshop's over. Joking.
We're going to sit here for the next 30 minutes. And now,
so now.
Here's the one from yesterday.
Yeah, go ahead. Well, I don't know. I don't even know. I'm not even following along. Where are we?
Keep going. Log into some stuff.
Yeah, log into some stuff. All right, here we go. So then you can RDP into your domain controller. Here's the domain controller. Kent has put BG info, packed that in the background so we can see that. There's a mention about this box right here, what it means, how it interacts with systems. We just say yes. I don't know what actual impact that has on this system. I don't know if it turns on network discovery. I don't know what it does, but now our domain controller can talk to other systems on the adjacent network. Here's our DC. What else is nice? Some of these tools we packed on this desktop. I know it's hard to see from here. PowerShell is admin. Double click that. PowerShell comes up. SSH to C2. This brings up the Linux box. Remember that Linux box we had, page 6 on the edge? This is that box right here in the background, prompting me to approve the signature presented by the SSH service. We're going to say yes. I'll make this font a little bigger here. And then we will run some commands. We're going to make a mess of this domain. We're going to do as much as we can here in the next 13 minutes. And then
we're 8 minutes in. We have a lab environment, and we've already logged into Linux and to a domain controller. So I think, Jordan, kind of the next steps here to install a bunch of tooling. So when BHS does a pen test, obviously we use a lot of different tools. The obvious ones are out there, like, oh yeah, we use Metasploit all the time. There's obviously ones that we even generally internally and have internally that we use. And we need to get those tools on that box wherever it is. For a lot of tooling we use, we do Git clone obviously quite a lot. But Python is a huge tool that we use for programming. Of course, when we use Python tools, we want to force them into a virtual environment just because dependencies are a nightmare on Python. So, Jordan, finishing through the deployment section here.
Just kind of scrolling around. We've established our RDP connections in and out. We've got our SSH box up. Remember, we've got this little neato script on the desktop. You can just double click. And now on that Linux box, we're going to install virtual environments. Kent, why do those really matter? Like, why do we care? Why do we use virtual envs?
I don't know. 5 years ago, we didn't, right? Anybody really familiar with Python? Not a one of you. Wow. Okay, so Python is a relatively high language for programming, and when we code in it, you're using bits and pieces from other people's code, and you kind of pull it all together to make something novel. Those bits and pieces all have different versions, and they oftentimes will conflict, where you might be making another tool that uses components from everybody else, but then you run into conflictions. So you use something called a virtual environment to force a new full package dependencies for Python to run your specific piece of code. That's kind of the idea behind virtual env. We're going through that now. Jordan is installing some tooling.
DonPAPI here first. We've installed a bunch of tools in the back end. Everybody give a shout out to Mr. P. Mills for writing C2 builders. This guy. Thank you, Phil. One of our absolutely brilliant testers. And now, okay, great. We installed virtual environments. We dropped DonPAPI onto that Linux system. If you don't know what that's for browser shredding, and we are going to get there here in just a minute.
Next up, BadBlood.
Next up, this tool. Kent, go ahead.
Yeah,
tell us what it does.
Anybody familiar with BadBlood? Okay, so a couple of you. So we've got a lab environment, and it's pretty much empty. It's a new domain mostly. We want to make a mess of it. We want there to be something interesting to look at. So we're using a tool called BadBlood. It essentially takes a randomization of first names and surnames, and a randomization of departments, a randomization of geographic units, a randomization of job titles, and just kind of puts them in a blender, and then starts creating random Active Directory things. That makes it look like we have users that are, have reasonable job titles and reasonable departments. then we kind of go one step further, and this is where this gets problematic. I'm not sure if anybody has ever tried to recover.
Should you run this in production?
Never. Well, I mean, no. So the idea being is we're creating a bunch of accounts. Active Directory recovery it's not impossible, right? But it involves like having more than one domain controller, taking them both offline, bringing one back up in recovery mode, and then forcing all the other domain controllers to read that one with authority. What you actually do is call Microsoft for professional services. That said, it's not practical to really recover Active Directory just because of the way that the RID master handles the RIDs, which is the last digits at the end of the SID. That all said, don't run this in production because yeah, it created user accounts. You can delete user accounts. What it will also do that you practically cannot resolve and go back from is it's going to take every object in Active Directory and it's going to take the ACL, which is like the access control list of who can do what on that specific object, and it's going to make a complete mess of it. It's going to do things like potentially add domain users to write access of domain admins, right? It's going to randomize the entire ACL of the entire domain.
All right, time's up, Nep. We're moving on to Impacket.
Practically speaking, can't go forward with it. Anyways.
Okay, so we deactivated our virtual environments. Remember, if you're in a Venv, all the requirements for that virtual environment are packed in there. Then, if you want to get into a different tool, you got to go deactivate that previous virtual environment and its construct and create a new one. So, again, with Phil's C2 builder, we just jumped into Impacket, activated its virtual environment and all of its associated requirements, and then we gathered AD users. So now we have a list. If you notice this last name here, Sean Holt, because that builder's still running in the background, I'm guessing this one is different. So still happening. Now we got Juliet at the bottom. This is just part of the process. The builder's still running. We're still racing through this. But now, as you can see, we've already got like a messy AD environment. We've got tooling up. And we can start to test like fun things we do on gigs.
Next up, service principal names. Anybody familiar with service principal names? Okay, good. Lots
this
of
one we are going to revisit.
Because it's probably not Billy. We're skipping
Correct.
it? Coming back? Oh, okay.
Go ahead. No, go ahead. Go ahead.
All right. What is the in the pathway for Microsoft? What is the correction or the replacement for service principal names? It's delegated managed service accounts. So that's now where we're going to delegated managed service accounts. Instead of having a static password that is part of an SPN, you now have Active Directory actively managing the password for a service account at 128 characters of, like, what is it, hex 64 or something. It's an unbelievably large key space that you can never crack the password for.
So let's secret stump. Next up, Impacket is almost sufficient to get us through a pen test these days. We've got Impacket, we can do just about everything we want. So we're doing secret stump against our workstation now, right? We've got our Linux box, we've got privileged creds, we dump credentials on that workstation remotely, here they are. There's something fascinating that happens in Azure. I don't know what this is, but it's something, and someday I will figure it out.
It might have something to do with that if you run Mimikatz,
clear text
Azure might tell you later
LSA.
on that you ran Mimikatz. It might have something to do with that password. I mean, they're obviously monitoring the
Yeah,
system,
what are you
so.
doing running Mimikatz in Azure?
Yeah, they know.
Yeah, they know. So the WMI shell, the WMIC shell that was in Impacket isn't as... you're going to have to not apply updates because WMI has been deprecated and removed from Windows 11. So now we move over to an SMB shell. Let's establish a semi-interactive shell on that remote target. Again, now we're targeting our workstation. And here we go. We've got a semi-interactive shell. Look who we are. Here's some commands we might run on that system. See how this goes. Turn off firewall, run, look at local firewall stuff.
You're thinking this is awfully contrived because we're running as domain admin, and that is true. We are, for sake of time, for the speed run. The reality of it is, at this point, we would have done something to coerce domain machine creds and be able to do the same thing off machine creds.
And if you're not ready, you're going to need to get ready to handle Kerberos. So let's just get a ticket for Kerberos. So we got a DO admin Ccache ticket, right? Not all environments support NTLM anymore, but most still do and most will for a while, but you're still going to need to understand Kerberos and how ticketing works. So again, a get TGT using the ticket granting ticket service to get a ticket issued back to us for Kerberos authentication. Let's take a quick peek, make sure that ticket landed where we expect it. As you can see here, we got our DO admin Ccache file, and then we're going to export it as var. We'll use that here in just a moment. We're going to install some tools that allow us to interact with Kerberos on a Linux box. There's a short list for you.
If this is flying over your head, so remember NTLM authentication, it's going away. It's going away. We're not going to use it anymore. And this basically went through and authenticated with Kerberos. We now have a ticket back from Kerberos we're going to use to authenticate instead.
And then K-list tells us what tickets we have on this Linux box.
At this point, we're now able to run additional tooling using the Kerberos authentication with the ticket rather than with the traditional username password.
So let's add a quick computer object to our domain here. We just added a low privilege PC. Remember, the default MAQ is 10 for all users on your domain. It's one of the things we'll check every single pivot, every single time we get a cred. We are going to ask your domain to create a computer object for us because certain things like ADCS might allow us to just get a cert.
Can I take that? The default for Active Directory allows you, any user in your environment, to create up to 10 computer accounts. The problem is that is a user joining a computer to the domain. The problem with that process is that we don't actually do that. What we do is we create a computer account with a static password, and then we migrate our context when we're pen testing to a domain computer rather than domain user.
Those of you in the offensive space, if you haven't seen Impacket's Reg Secrets, it is a significant improvement on secrets dump and will bypass a lot of the signatures associated with secrets dump. Why? Secrets dump used to create a temp file that was 8 characters and drop it to temp. Pretty easy to signature, right? Reg Secrets does this filelessly. So, same content, less signaturability. Is that a word?
Less for with signature ability, I like it.
All right,
I'm gonna start using
extras.
it.
Look at us. We got through a lot of the tools.
Okay, who's familiar with ADCS, Active Directory Certificate Services? Everybody familiar with the vulnerabilities therein? The big vulnerability, if it just was distilled all the way down, the big one is you might have a scenario where your ADCS is configured for client authentication and for what's called the enrollee supplies subject. It essentially means that someone can request a client authentication certificate, but do it in a way that they request it for somebody else. So that's kind of distilled down. It's a very common problem. It really, kind of the research came out on it about 4 years ago now. The reality of it is it's existed ever since ADCS was a thing in Active Directory. But practically speaking, the research came out about 4 years ago. We're still seeing it on organizations that we do pen tests for where they have this misconfigured. When we talk about why it's misconfigured, one of the big things that came out is ADCS is typically used for integration with third-party products. So maybe like you think of Broadcom, VMware, you might have another third-party solution that needs to have some sort of context awareness of authentication in Active Directory. A way to do that is ADCS. So the integration like booklet to tell you how to do it says, use ADCS, create this template that users are going to use to create these client authentication certificates. And page 1 told you how to do it, and page like 2 through like 15 told you how to do it securely. So as typically sysadmins will be like, well, it worked on step 1, so I'm good. That left a gaping hole for security, and that's why those ADCS is still misconfigured. I have searched for quite a bit, a lot of old integration manuals, trying to find ones that did this, and there were a couple. I think I had about 3 examples. By the time I was really doing a lot of the research, a lot of organizations that had that media out there were trying to pull it as quickly as they could. So you ended up trying to find it on, Internet Archive and that type of thing. But there were definitely integration platforms that were telling people to go create these vulnerable conditions in Active Directory. Now when you do that in ADCS, if anybody's familiar with doing AWS and S3 buckets, you can no longer just create an S3 public bucket. It will now prompt you like 30 times, are you sure you want to do this? This is bad. In Active Directory, when you create these vulnerable conditions with ADCS, it now prompts you, are you sure this is bad? It will tell you that going forward, which is good.
All right, so Kent missed an opportunity to tell me to trust the process. I missed a command to create a directory where we stored the certificate templates, which we just configured ADCS in this endpoint, right? And downloaded a bunch of templates, applied ACLs to them so that certain users could use them. Now we're in Certify, and we're using Certify to go analyze the Active Directory Certificate Services environment to see if there's anything interesting out there. Also in the background, I went ahead on this workstation, which you'll see right here, and launched some browsers. There's going to be something interesting. Hopefully we have time before we get kicked out of here. Again, we appreciate Wild West Hackin' Fest and the whole crew giving us an opportunity to come up here for a few minutes. Now let's do a cat ADCS star.txt. And we see some vulnerabilities. Remember us creating a computer object? Now we can shred the entire domain again using the computer template.
To give you context there, those integration processes with ADCS would also say it's okay to use domain computers as an enrollee. The problem with that is now that you know that you can just go create a computer account, which is a member of domain computers, then you just pivot and be able to use that template in ADCS and get to DA relatively easily. So, where you at, Jordan? I wasn't even paying attention.
We just got a domain admin PFX file, and those of you who are unaware, this is called the unpack the hash attack, where we go ahead, we get a certificate, it's PFX, then we can use that PFX to unpack the response when we request a TGT from the domain. Right? That includes enough encryptable, decryptable material that you have the key to unlock the domain admin's NTLM hash on the way over. So this is called the unpack the hash attack. NTLM hash, we win again. Boom. Next up, we are going to go visit this cool place called testphp.vulnweb.com, and we're going to save some passwords in our browsers. Anybody familiar with browser shredding? Yes, this is the game. And these days, if you haven't seen Stealer Log, Stealer Malware 101, if you're unaware of what this stuff is, you really need to go look. Because it's highly probable that a portion of this room has been exposed via browser theft. Anything to add there? While I add, I think this is Edge.
So have I been pwned? Pretty much everybody knows what that is. Put your email address and get the results of where your data has been breached. The reality of it is that is a incredibly sliver of the information that's actually out there. And BHS uses a tool called Flare that helps us kind of analyze some of that data that's out there. If you look too hard, you'll find like a Neopets password for my account from like, I don't know, 1998. And I can't get rid of it, so it's out there, and now I just make fun of it.
So what I'm doing here, I'm saving passwords in these browsers, and then we're going to go take a quick peek. Remember that first tool we installed, DonPAPI? That is 100% a brilliant way to shred browsers. And so these days, kind of, we're not maybe having as good a luck finding and compromising credentials on networks. But if we can get a hold of admin creds and shred some browsers, then we are in business, because people unintentionally and consistently store passwords in browsers.
Now, when browsers save passwords, right, to be reused, they have to store them in decryptable so that they can be replayed later on when you go back to that website, which means they're encrypted typically, hopefully, somewhere on your computer, either in registry or in the Hive, or it's going to be on the file structure of the user's profile for that browser. DonPAPI helps us kind of normalize all that, and essentially says if you have local admin in the machine, you have all the information necessary to decrypt those stored passwords, and it will do that. It'll go pull the keys, the decryption keys, usually the machine key, to find them, and then it will go through all those places that browsers store that data, decrypts it, and then gives it back to you. So
we got one.
There you go. Where that might be more of an issue is if we compromise a sysadmin's machine where they have their hypervisor password stored in their browser. There you go. That's why this becomes very practical very quickly.
We did it!
You missed SPNs.
Oh, yeah, you want me to go back?
Okay, service principal names. The replacement for that is delegated managed service accounts. Delegated managed service accounts, the password changes but using Active Directory. And that is in 2025 plus. There's now a migration path from service principal names to DMSAs.
All right, deactivate.
You could also use standalone managed service accounts or group managed service accounts. If you're interested in all of that, we actually have a public lab that we also have on, I'm trying to think what class it is, Defending the Enterprise. So if you go to github.com/defending the enterprise, there's a public repository there that teaches you how to go through and create group managed service accounts instead of SPNs.
There they are. Is that what you wanted?
That is. So
okay.
The problem with service principal names, traditionally, is that you could essentially convince Kerberos to give you a portion of the hash back, the password. So you don't end up with the password, but you end up with the password hash. We then go through a password password recovery process with GPUs and such and try to recover the passwords. That said, if someone said, are SPNs bad? The answer is no, of course they're not bad. It's actually a secure way of handling service accounts. However, the problem with it is if you create a service account with a 10-character password, it's not actually safe. You create a service account with a 120-character password, which nobody's doing, that is safe. And it's even if we do capture the hash on SPNs, it doesn't matter if it's 100-character password, that type of thing.
Holy cow, Kent. You just covered a ton of material, and I am blown away. You kept up.
It doesn't matter if it's 40 characters.
Awesome.
This is Azure Sentinel.
Okay, so now, let's say we have 5 minutes left in class. Why wouldn't we look at some detection engineering, right? So you expose RDP to the internet. Do you know what happens? It completely
gets hammered. Yeah.
Oh my Lord.
It takes. So we've done this so many times that we have an expectation of what happens. Yeah. So much so that we're able to now track over a course of time where these adversaries are. I don't know, but anyways,
we had a class recently where it was absolutely fascinating, and we said, "Holy crap! Was it the Bulgarians? What the hell are the Bulgarians doing with SSH?" And then all of a sudden an SSH 0-day comes out of Bulgaria where we're like, oh.
So
got it.
If any of you ever seen an advertisement for threat feed intelligence, I want you to tell you it's not that exciting. It's definitely not worth millions of dollars. What you can do instead is just set up some honeypots, monitor where that traffic is coming from, and you've kind of created the exact same thing. The next step of course, of this, taking those attack IP addresses that you get and just forcing them to like fail to ban or into an IP block list.
So who's going to be on the top today, Ken? What's your bet? Oh, it's Bulgaria!
Jordan, how long has this system been up that we've been catching logs?
4 or 5 days.
4 or 5 days.
Oh, that's awesome.
Followed by
And this
Romania.
is only the last 24 hours. This is the last thing we're going to show off. We're switching that to 7 days, and we're going to go to max. Now, we teach classes, remember, so I'm sorry to do a little marketing. If you want to come hang out and learn all of this stuff in depth, come join
I can
us in
talk
Denver.
all day about any of this stuff. So,
Could really do some with the new Sentinel plugin for VS Code. Just freaking
yeah.
really do some real
And it's Bulgaria.
Sentinel is
Look at
super
these
powerful,
guys
especially with the
go.
playbooks that they have on there now too. One of the other things we come up with is checking the difference between the attacks that come from that are SSH based.
This is approximately 36,000 failed logins per day from just Bulgaria on 2 RDP servers.
It starts about 45 minutes after
So
the system's
don't
up.
expose RDP to the internet.
Any questions?
unless you have MFA.
I know, that
Yeah,
was heavy.
MFA.
Go ahead.
Browser password shredding and all that. What about like all the new security features that Google says that they have in it?
So this is interesting because a week ago, Chrome worked. This week, patched Chrome does not. Cat and mouse. Cat and mouse. It'll work again for a few days, and then Chrome will catch up. And it's you have to have access to the system DP API key. You got to be able to get that. You got to be able to get to the browser. So there's a lot of places that you can make missteps trying to get a hold of browser
And
creds.
the key thing to think there is that the passwords stored in browsers have to be decryptable. So that cat and mouse game just continues because of
Third-party plugin like that, or new.
that's better. Yeah, once you go, the point is to go to a password manager that you can trust. So not like LastPass would ever get
Yeah.
breached, right?
Thank you all.